Good evening to you guys. So the first thing to remind me, let me introduce Bob. To those of you who don't know Bob, he's been with us well, a long time, and we've done webinars, but I'm sure some of you guys don't know him. So he's our guest speaker today, and he has over 30 years of experience in the EX world. He's a Comp EX instructor. He's also an instructor for the IC EX Comp PCSK. He's a member of the US UL STP committee. He's a, oh gosh, I got inspector. So he does a lot of inspection. Hey, it's been a while now. And so he's very, very, very qualified to do this job. In fact, in all the webinars we've done, I haven't seen him once in trouble. You're not able to answer a question. So you guys see how we do today. But before I let him talk, I need to take a few moments to introduce GMI. I will be very brief. So Bob, you can start the presentation.
Okay. You see it?
Yeah. Okay, so let's go to next slide. So, well, speaker details we talked, Bob and Paolo, VP of Sales of GMI. Let's go next step. Next slide, Bob.
Yeah. It's a little slow.
So we are a company, GM International, designing, engineering, and manufacture a complete range of IS and SEAL certified devices that are used in all automation packages such as DCS or ASD, fire and gas, and so on, in most of the industry, from oil and gas to food and beverage. We have over 40 years of experience, and we're very proud to make our product here in Italy, in our headquarters near Milan. We are, on the other hand, global players. We present all over the globe. Next. And because we make safety products, our product are safe product, we try to take special care. We take special care in manufacturing them. So we have a state-of-the-art technology that we use. We use full product traceability. We have 100% testing. We are compliant to all the rules and regulations that are applied every day, a new one. And we are SC3, so C3 certified as a company, not only as product. And of course, we are trying to be, because we make safe product, we want to make sure the world is a safer place for us and for you guys. So next slide. These are the product we manufacture, from IS barriers, safety relays, with and without line monitoring. We have isolators, also SEAL certified. We have power supply, which are EX and SEAL certified. We have multiplexers. We have a bunch of termination board used to interface with the most common system out there. We have ARC multiplexer. We have SPDs. And we have a loop indicator, and we have a service division which provides training and services in the EX and SIL domain. So functional safety and EX. So we are present, as I said, most of the world. So we have 10 GMI offices, about 75 distributors. We are about 200 people, and we have done thousands of installations around the globe. The following slide, Bob, represents some of our customers. So most of the system vendors, from ABB to Yokogawa, many EPCs, a lot of OEMs, which we supply our product, like skids, wellhead packages, compressor, weight machines, a lot of stuff that goes in the oil and gas. And of course, many end users use our product, and we are on their AVL. I believe this is it for GMI. Yes. So now we are in the heart of the presentation. Let me give you a hint here. There's only one way for you guys to talk to us, which is through the question and answer box. If you pose the question in the registration, we will answer it at the end. So no need to repeat the question. And we will try to, on the other end, see if we can answer all the questions we have today. Okay?
We'll try.
Bob, disappear. I'm here checking your question and answer. Bob, it's all yours.
All right.
Please try to keep the question related to the subject. We have had a lot of questions related to different subjects. We will have to answer those in different webinars. Okay, go ahead.
Well, thank you, Paolo, and thank you all for being a part of this. This was actually this is the first time we've done this webinar, and we've done quite a few different webinars in 2020, and Paolo and I spoke about various topics, and I thought this might be one that would be of interest. And a lot of times we think about EX mistakes and we think about that this is all people in the installation side of things. And when we really start looking down deep and start seeing some of these issues, we actually can find that in many cases, it starts at the very early stage. Now, this particular report, which was an interesting report, came out quite a few years ago. It didn't deal specifically with EX mistakes, but it just talked about what are some of the biggest areas of concern that are some of the root causes for hazardous, or not necessarily hazardous, but industrial accidents. And if we see in this slice of the pie, and again, I'm an engineer, so I think if it can't be the engineers, it's got to be those idiots out in the field that are doing problems. But if we actually notice here, a lot of the problems actually result at the very early stages in specifications. And so what this presentation will do is actually talk about the various mistakes at the various stages, because what I typically find in many cases is that when I go in and do a final inspection, maybe equipment is installed properly, it's absolutely done perfectly. However, it wasn't the right equipment in the first place due to various issues. So there's never really a time that people set out to say, hey, I'm going to create some mistakes today that will result in a disastrous situation 3 years from now or something like that. We don't obviously deliberately try to make these mistakes, but it is something that we have to take note of as engineers and designers, that in many cases, these mistakes that ultimately do result in major issues can come at those very, very early stages. So that's really the intent of trying to kind of cover some of this information today. So how do we define mistakes? Well, mistakes can come from all different kinds of areas, but we basically use in the EX world these documents that more or less allow us the ability to kind of as check sheets, if you will. These are the 60006 or 79, I have typo there, 60079-17 standards are really the relevant standards that we do and use as inspectors. There's EN versions of it, there's different country versions of it, but the base standard is that IEC 60079-17. The installation standards are all over the place, but the main IEC one is the 60079-14. So the intent is that when we're designing systems, we use the -14 system as well as country-specific wiring regulations, as well as client-specific wiring regulations. And then we follow up with that with our inspections based upon the 17 standards. So if you have not seen the -17 standard, at the very back of the -17 standard, they have inspection schedules. And this is what, as an inspector, I use to go in when I'm doing a detailed inspection. And we have different grades of inspection. So we have detailed, close, and visual. And there are inspection checks that we use to go through the equipment that's installed. I always tell designers, hey, look at these inspection sheets before you call an inspector in, or actually, ideally, make sure that you're following these as your check sheets for even writing your specifications, because these check sheets are basically the information that people such as myself, when we come in, are going to be using to make sure that we catch those mistakes, those errors that are made. So it's important that we use this, we're aware of this. And again, it's a handy tool. It's available. Use it even as a designer, because this is going to help make sure that once that product is ready to leave, that it's safe. And not only that, but the users where we're installing and maintaining this equipment, we want to use this as well. So one of the biggest mistakes that I see, and this really comes from one side of the business, as Paulo mentioned, we do training, we do inspections, we also are a supplier. We're a supplier for GMI products, but we also supply other EX equipment as well. And as a supplier, we get calls and inquiries from various people all over the time that are asking for EX equipment, which is great. That's a big portion of our business. And one of the biggest mistakes that I always see is that I'll get an inquiry in and somebody will say, I need a motor starter and it has to have this, and it needs to be suitable for zone 1. and that's about the extent of it. Now, that doesn't mean that that inquiry that I got was not good, but that's really not telling me all the information I need in order to generate a quotation, right? Zone 1, okay, is it ATEX? Is it IECEX? What is the standard? What do I need to comply with? Things like gas groups, is it 2A, 2B, 2C? What's my T code? Obviously, EPL or zone of suitability is the big one, and that's usually the one that everybody gets. But other than that, sometimes we don't get all that information. Another one that gets overlooked is the ambient temperature. If a product isn't marked, it's a default to -20 to +40. However, we notice in many parts of the world, oops, my little thing is clicking here. In many parts of the world, +40 is not going to be sufficient. We have higher ambience, especially in the Middle East or on the Gulf Coast, that we see ambience of +50 or +60. And certainly in cold temperature areas, we can get below -20. What is our IP rating? Again, the certification and what kind of environmental conditions is this piece of equipment going to go into? So I figured just to give you an example of some things, I put together some labels to kind of give you thought, if you will, to kind of take a look at the label. See what you see on there. Is this product that you see here suitable for my requirement? My requirement is zone 1, 2C gas groups, must have a T6 or better. Well, T6 is the best. I have a high ambient of +50 degrees C. I need a minimum of IP65 and I need IECEX certification. So when I'm looking at this label here, I see a couple things that step out right away. Number one, it's only suitable for +40 degrees C, right? And I don't see any reference to either an ATEX, although I know there is an ATEX certificate for this, but there is not an IECEX certificate for this particular piece of equipment. So I couldn't use this particular piece of equipment in this particular environment. Looking at another label, here's another example. Again, without going through all the protection concepts and how to read a label, which we have covered in some of the previous webinars, but in looking at this, I know EXD MB is suitable for zone 1. Doesn't tell us right there on the label that it's suitable for zone 1. The gas group, it's suitable for 2C. It has a T5 at +80 and a T6 at +70. So, however, one thing I don't see on this is I do not see an IECEX certificate number on this particular piece of equipment. Again, we're almost there, not quite. Now here's a label for a different piece of equipment. Now we notice on this one, it does say IECEX, and there is a certificate number on there. However, if we look closely at our protection concept, EXNA and NC are only protection concepts suitable for zone 2 applications. And notice it's 2B and not 2C. We do meet the high ambient requirement, but there's also another thing. There is no T code associated with this because this is a component. And the reason why we know it's a component is that we see a little U at the end of the certificate, which we'll talk about a little bit further in this presentation. So again, another example of a product that we just could not use. Now here's another example. This product, if we look at the label kind of closely, we see ATEX, we see IECEX, but probably some of you have keyed in on this already. We see a couple issues. Number one, we see a 2B plus H2 and a T5. Again, we don't meet the requirements of 2C and we don't meet the requirements of T6. So again, just other examples of labels that we can tell. And this is all part of our inspection process that we go through this and we make sure we look at the standard or we look at the certificates, we check the labels, and when we start seeing these issues, this is where we start highlighting them. Here's another example, okay? Notice that this is an old EN label, okay? The 50016 is from an older standard. However, it does have an ATEX certificate. But there is a couple issues here. Number one, we would want to know, can we install this in a particular hazardous area? We see that we have some brackets associated with this. So it's providing protection downstream. Can we actually install this into that particular environment? And we would have to do some further digging on this one, but basically, based upon this information here, as it is, we could not install this without further assessment because it doesn't meet the requirements. Here's another example, and I promise you we won't go through too many of these, but I just want to give you an example of some of the things that we do see and make it very clear. Notice in this particular instance, this is certified. It's to an older standard, which isn't necessarily discounts this from being in use. We wouldn't want to install this under the latest standards unless we have new markings on it, because those are old markings. But we notice that again, NA is a zone 2 protection concept. It does have gas group Roman numeral 2, which is actually telling us in effect it's good for all gas groups. And notice again, it's ATEX only, and our ambient is only up to plus 48 degrees C as opposed to plus 50. So a couple issues. Here's another example. Again, it's ATEX only. And I don't actually see a certificate number on this particular piece of equipment, but it is a zone 2 product only. Again, good for gas groups. We don't meet the requirements of IP65. It's only IP55. So again, it takes a little bit of time. We go through this, we identify this. Now, does this mean that these products are not suitable for hazardous locations? No, it just means that they are improperly applied for this particular application that I've called out. So the big important takeaway from this is that when we're specifying things, and this is where I see the big issue here, this mistake is usually a mistake where the engineer, the specifier, writes down the specifications. Then it goes through that supply chain process. It winds up in the hands of possibly a purchasing agent, sends it out to bid. If it's an or equal type situation, well, first off, the design must be such to where the engineer is making sure that they take into account all of these characteristics, making sure that the original product, if it's a product specification, that it ensures that it meets that. But then a purchasing person gets their hands on it, says we can buy a similar product for maybe 10, 15, 20% less. It's always important, obviously, the engineers, designers, the responsible person is reviewing that information to make sure that there aren't those holes. So it's important that everybody within this supply chain, everywhere from the purchasing people, from the engineers, designers, the suppliers, we have to know this information as well. And if we don't, this is where things fall apart. So we want to make sure that we're selecting the appropriate product at the appropriate time that meets the client's specifications. The important thing to note
for information must be
correct. I want to make sure. Yeah, the important thing to note too is sometimes the client specifications are so vague or not very detailed that we have to make guesses. And I don't like guessing. So if we're responsible for writing those specifications, make sure that they're very clear, very concise, there's not conflicts. That's usually another big issue, is that we'll have conflicts within the specifications. So address all this good stuff. We're much more likely to make sure that you get A, the product that you want, and B, it's safe.
It is the right product for the application. So, okay, we have a question here for you guys, making sure you're still with us. Let me launch a question. What is the IEC standard that provide guidance for inspection of EX equipment and installation? There are 4 standards there, the 079-1, 14, 10, or 17. So please, there is no judging here, just answer, click. We don't see who's clicking what. I had to check my answer myself. So I brought it down here, make sure it's the right one, because I would not know the answer to this one. But, Bob gave me a hint. So I think those, Bob. You have A, B, C, and A. So we do have 2 A's here.
Yeah, we got, 2 A's. 2 A's make it right.
But anyhow, you guys know that you either click on 1 or click on 17, And the difference, quite different, but it's a typo there. It's A, B, C, D. Anyhow, okay, give it a couple of more minutes.
Biggest mistake right here.
actually, because we need to move. Yeah, it's your mistake. So before we get this, let me see. There's a question here. How does the IP rating in this application affect the certification? Well, IP rating, it's always an issue, right?
So yes, EX equipment generally has minimum IP ratings required. Most EX equipment requires a minimum of IP54 or greater. However, IS barriers only require IP20. Flame-proof boxes actually, or flame-proof equipment actually does not require an IP rating. But so IP ratings are important. They're part of the testing, if you will, for EX equipment. So it is important to have.
All right, so the answer is for 60% correct, right, Bob?
Yes, yes.
It was the second A, so it was 60079-17.
Right.
All right, guys, you're doing good.
Yeah, so just so you know, -1 is the standard for building flame-proof equipment. 14 is the design standard, which I mentioned earlier. 10-1 is actually area classification, but 17 is the correct answer. That's our inspection standard.
Okay, good. So we can move forward. There's also a question about ambient temperature. You know, what how do we define ambient temperature? What is the solar morning, you know, day and night? I guess I don't.
Yeah, there is actually there is some details on that, and I tell you what, the question goes into a lot more detail, and I will answer that one offline. So I've got your contact information, and yeah.
Okay, dismiss that. All right, let's move forward then, Bob. Otherwise, we'll never reach the end.
oh, let's go back here.
Mistake number two.
Yeah, modifications to EX equipment outside of what is allowed.
That's a big one.
Yeah, this is one that usually, you know, takes place obviously once it reaches a particular point, either if I'm a skid fabricator or if I'm out in the field or something like that. Additional entries into EXD enclosures is one of the biggest issues that we see. People take EXD boxes and they start doing things to them that are outside of the scope of what is actually allowed. So first off, do not drill into an EXD box, okay? You are allowed as the manufacturer or as a manufacturer's authorized repair or modification center. It is allowed under those circumstances, but once it leaves those locations, don't start drilling and tapping into EXD boxes. Definitely don't do that. The other thing is, and this is one where people sometimes get a little bit confused, but adding additional components inside the enclosures outside of what is allowed by the certification. So it's really important to understand the moment that we start adding additional items on the inside of, say, a flame-proof enclosure, that changes a couple things. Number one, it could affect the temperature code by adding another heat producing or resistant type device on the inside of a flame-proof box. That could affect the overall temperature code. Now, generally speaking, that's not such a big deal. It can be a big deal if you've got very high heat producing devices. What the major concern is that explosion-proof or flame-proof boxes are designed to contain internal explosions. And so when we modify or do something different to the inside of this enclosure, that potentially could result in pressure piling. And so we don't want to see that, which basically means that this enclosure would fail if we had an explosion on the inside. So always be aware of what you can and cannot do. If you have questions, always reach back out to the manufacturer. They will tell you what you can and cannot do. If you're changing a like for like, that's almost always acceptable, meaning that if I had a Siemens contactor and I wanted to replace it with another Siemens contactor, fine, no problem. The moment I say, well, I want to take that Siemens one out and I want to put an ABB or a Schneider or something like that, check with the manufacturer, okay? Make sure that that's allowed per the manufacturer. Things like O-rings, Teflon tape, labels to existing EX equipment. Now, putting labels on, generally speaking, it is a requirement that EX equipment has labels, and they need to be visible, and they need to be durable, and all that good stuff. But the moment that we start riveting or drilling or doing something to attach a label to an enclosure, depending on the type of enclosure, could be EXE, EXD, be very careful about doing that type of stuff. Again, check with the manufacturer. The moment we start modifying those enclosures, we could affect E or A, its IP rating, if it's in the EXE box, by putting a label on it, drilling it, putting nuts and bolts. We want to be very, very careful about putting labels and how we do it. Okay.
Can we, Bob,
Things like O-rings to give it additional IP ratings. Again, we don't want to add O-rings to existing EX equipment, even though it might sound like a great idea. We don't want to be doing that. Teflon tape to glands, we don't want to do that. So modifications.
What about, we have a question here that is directly pertaining to this from Rob. What about denso tape around the flame path?
Yes, denso tape is definitely allowed around flame paths. It's important that when we put denso tape, we apply, and there's certain requirements depending on the gas group. So I believe, and I have to go back, Rob, on this one, but I believe for 2A and 2B gases, we can put a single layer, and it may be 2 layers on, and I actually think we can do it on 2C enclosures as well. I think we can only put 1 layer of denso tape around a flame-proof flanged enclosure or threaded enclosure for that matter. But I think with 2C gases, we can only put 1 layer. And it's always important that any time that we open up those enclosures to do any maintenance whatsoever, we should replace the denso tape.
And if we do put a label, because it's a requirement, maybe we have to put a tag, can we drill it or tap it, just silicone to it?
No.
Or cannot do it at all?
No, well, generally speaking, the manufacturer, the moment that we're starting to modify that enclosure by drilling or putting something additional into it, we want to check with the manufacturer on what's allowed and what's not allowed. For example, drilling holes into EXE enclosures, increased safety enclosures, is generally allowed, okay? So if we drill a hole to put another gland into a sheet metal box, that's generally allowed. But we still have to be careful on where we put it, and the manufacturer will give you guidance on that. But the moment that we want to say, take a label and drill some holes and put nuts and bolts and do all that good stuff, that I would be very leery of doing. So in that case, if you have to put a label on in the field, look at various adhesives, to be able to put something on there that gives you as permanent as possible to put some sort of label on there.
Okay.
So continuing on here, oops.
Yeah.
So here's a couple different things. And again, this maybe highlights a little bit here with regards to cable glands. In this particular instance, we've actually, this is somewhat modifying, and it's a little bit of a different issue, but we've basically taken 2 adapters, if you will, and used a cable gland, and we put IP washers. So the important thing to note, and this is actually a mistake that's a little bit further down the road, during the installation, we can only use 1 accessory with a cable gland, meaning 1 thread adapter. Don't use multiple thread adapters with regards to installations. The picture on the left, that's more from a standpoint of, obviously the tidiness is a little bit, not the best, but here's the important thing. We want to make sure that we have a drawing of that particular product before we do an inspection, to make sure that everything that is on the drawing is accounted for and there's not additional items that have been added to that particular enclosure once it's been installed into the field. If it has, then we want to make sure that that's noted in our inspection schedules. We want to take that information back, and we want to make an evaluation of whether or not did it change this product by adding an additional terminal. What has that done to its EX certification? So be very, very careful when we're starting to modify existing EX equipment. Now, looking at this particular product, we don't know if there's mistakes on this one or not, right? I mean, it looks really good. And I'd venture to say this probably is perfectly acceptable. But if you notice on the inside of this enclosure, we have a lot of different components. That's why one of the things that I always ask for when I'm doing an inspection is hand me the drawings. Let me see what the drawing, give me the general arrangement drawing of actually what should be in this enclosure. We see that we have relays. It looks like we have some associated apparatus. We have a lot of components in there. I want to double check to make sure that everything is captured on that drawing and nothing has been added in the field that could affect its certification. Okay, that's an important thing to note. Notice, however, also that they've got cable glands of various types and sizes, which is perfectly acceptable, right? But we want to make sure that where those were plugs were, we want to look at the drilling envelope. Was this drilled in accordance by the GA drawing? Was it done by the manufacturer? Was it done by somebody else? We want to take note of that. So there's a lot of little things that we want to take a look at. And obviously, this is a new piece of equipment, but we'd want to check the flanges and the bolts and all the other good stuff, and certainly the certifications. Now, this kind of goes along this same line, but this is an example of two different enclosures from two different manufacturers. They're very similar. They're basically both flame-proof junction boxes. The one on the bottom, if you notice there, it says EXD 2B plus H2. The one on the top says EXDB, which is the new EPLs. And it also has IA and then 2B plus H2 with the T code. Now, why do I highlight this? Well, the one on the top is basically saying in that particular enclosure, I will have associated apparatus actually installed on the inside of this enclosure. That enclosure has allowed me to put, say, an IS barrier on the inside of this enclosure. If I look at the label on the one below, I don't see the IA, meaning that if I take a look closely on the inside of this enclosure and I start seeing associated apparatus, I'm going to take a closer look at that. I want to make sure, hey, wait a minute, this label isn't appropriate for putting intrinsically safe barriers on the inside of this flame-proof box. So it's important to understand, even though both of those products are very similar in design, but they do have different labels and they mean different things. So it's really, really important that we look closely at these labels and compare that versus what's actually installed. And again, this just shows you a little bit more as far as the use of Teflon tape. Here we have on the right-hand side some examples of some stopping plugs that were non-certified. Now, these could have been traveling plugs, right? Where somebody installed them with the assumption that cable glands are going to be put into those enclosures. That's fine. However, those would have to be removed before that final detailed inspection and replaced either with a certified plug or a cable gland. And by the way, the reason why we don't want to use Teflon tape, as what you see on the left-hand side, Teflon tape is fantastic for use on plumbing and gas lines and all that good stuff. The problem is with Teflon tape is that the threads between the enclosure and the gland actually acts as a flame path. So by putting Teflon tape, you've basically clogged up that flame path, which could increase the pressure that could be escaping in other flame paths. So we don't want to use Teflon tape immediately. End of story.
What if we put grease on the flanges? I mean, it's a question we got to.
Yeah, grease on flanges. Yeah, you want a non-hardening grease. The standard, the -14 standard basically says something to the extent of a non-hardening grease. Now, we don't want to use things like silicone, but thread lubricants are perfectly acceptable. Usually the manufacturer will tell you that the information of what they would recommend. And it is recommended to put some sort of thread lubricant on flanged and threaded designs to keep them from seizing, because that is a major issue.
We do have a lot of questions. I don't know if you want to answer some of those, Bob. For example, can you have a 90 degrees elbow, bushing and cable gland together, or this will be considered two adapters?
Yeah, Kenny, thanks for asking that question. Actually, we'll hold that question because I think I have something about that a little bit.
Okay, what about, can you confirm that the barrier glands are needed in a 2C gas group for EXD box, or you get around with the cable type?
Yeah, so actually, in the latest edition of the Dash 14 standard, the cable gland selection charts have changed. So it used to be if we had a 2C enclosure, pretty much it was a default if there was any arcing or sparking inside of that 2C enclosure, which I assume if you were using flameproof, you would have to use a barrier gland, period, end of story. However, the standard has actually changed, and now it's based upon the length of cable. And Rob, I will answer that one off, and I will send you some information on that. But basically now is that if the cable run is longer than 3 meters, the use of a barrier gland is not necessarily needed for those applications. However, if the cable run is less than 3 meters, then we might have to use a barrier gland for all of the other EXD gas group applications. So it's important to look very closely at the new requirements, and it's in 60079-14 in tables, I believe it's in section 9 through 10.
Great. How about when we torque these cable glands? We have to torque them to a certain,
Yeah.
what, recommended
Yes.
by the
Right.
manufacturer?
So the glands have to be installed in accordance to the manufacturer's recommendations. One of the things that we teach in the both Compex and the IECEX is that we assume electrical technicians do not have torque wrenches. So we say things like spanner tight. Okay, now my interpretation of spanner tight versus somebody else's interpretation of spanner tight can be different. But when I actually go and inspect glands as an inspector, if I can remove it or loosen it up with my hands, then it's not tight enough. We
And then
just
it's
want to be
wrong,
very,
yeah.
very careful that we don't over tight them. And that's a whole nother story that you can get into. Some of the cable gland manufacturers have a metal to metal surface where you cannot over tighten it. It'll basically stop. Other manufacturers have now, one in particular has now come up with a design where it actually has gauges on the gland that tells you don't go any tighter than this line. So there's different ways of addressing it. But basically,
So they
what
have to be properly tight, not too much, not too little.
we don't
So
say
according to recommendation of the manufacturer.
yes.
You said no Teflon, how about any, and we said the grease was okay. How about Loctite? Is that something you can use?
No, Loctite. Loctite will basically turn it into a permanent.
Yes.
We don't want to do something like that. So we want it to be a lubricant that will be a non. Like I said, the standard basically says a non-hardening grease. So I would say
Loctite is hardening. That's a job of it.
Yeah.
All right, we have still more questions, but let's move forward. Otherwise, we never reach the end, and then we see how we get along.
No worries. And by the way, if we go a little bit long, that's okay. If anybody wants to stay around, we'll try to.
If you want to stay with us, we are here for you guys.
Yes. So mistake number 3. This gets into cable glands and accessories and the things that we look for: non-certified glands, improper installation. Are we using the appropriate accessories? Maybe using EXE into EXD. One of the things that usually, everybody understands this for the most part, but one of the other things is failing to take note of the special conditions for safe use on the installation of cable glands. Every cable gland that you will buy will have an X at the end of it in their certificate, and that means it's a condition for safe use. Generally speaking, it means that it's not meant for portable equipment, meaning that it's meant for a fixed installation. However, some cable glands in their X actually also have additional information in there, such as this cable, if you're using it with that particular cable, must be clamped within a certain distance of the end of the gland. So making sure that we look at the X condition on the installation of cable glands is important to understand that. Because again, as an inspector, I'm going to look at the cert, I'm going to look at the special conditions for safe use, and I'm going to see whether or not you're actually in compliance to the conditions for safe use. Again, I mentioned about reducer fittings in glands. One of the other big no-nos is using a stopping plug in conjunction with a reducer fitting. We generally do not allow that, okay? So if we have an empty entry, we need to use the correct size stopping plug, not multiple stopping plugs, or a smaller stopping plug with the reducer fittings. And again, multiple reducer fittings. So this just shows, I mean, a little bit, some of the things that you will kind of see on the left or on the right-hand side. There's an example of a stopping plug that's actually a traveling plug that was installed into a transmitter that had been installation. That should have been replaced with a certified plug. Obviously, the picture on the left-hand side is a little bit different, but what you're actually seeing there is the armor is not proper, but also we see a little bit of deformity, if you will, in the compression around the gland itself. So that's the back end seal, and that's caused by cold flow, which we want to be very, very careful about also when we're installing and maintaining cable glands. Now, I think this was part of the question that actually was raised a little bit earlier with 90-degree fittings and reducer fittings and adapters and everything else. So the picture on the left-hand side, it's a little bit difficult to see, but we have a reducer, we have a 90-degree, then it looks like we have an adapter, and then we have a cable gland. So in that particular instance, I'd say, hey, we've got a little bit too much here. We'd want to go back and take a look and see, hey, what can we actually do? Now, to answer the specific question, can we use a 90-degree fitting with a cable gland if, say, for example, that 90-degree fitting had the reducer fitting going into the enclosure and then the gland going straight into the 90? I would say generally, I would say yes. There's a little bit of a gray area, if I'm not mistaken, looking at the standards, because it doesn't necessarily specifically state, if I'm not mistaken, the use of, say, a 90, because we basically are saying the gland should go straight into the enclosure. But this type of installation is not uncommon, except we basically have a little bit too much there. Now, the picture on the right-hand side, we see a plastic gland going into a flame-proof box. You might immediately think that that is a fault, but that may not be a fault, because this might be used if we had IS in the particular device there, maybe we could use a plastic gland, but that's a flame-proof enclosure, and we know plastic glands are not suitable generally for flame-proof enclosures. So the picture on the right-hand side, that's a gland issue. The picture on the left-hand side is too many accessories.
What about
now, these are pretty obvious, but what you see on the left-hand side, those are stopper fittings or seal fittings that we would typically use here in the United States. The person that did this obviously didn't have any understanding of what they were doing. So those all have to be actually sealed up with a compound type material. They have basically spent, that box, what you see there is literally probably thousands and thousands of dollars, but they have defeated the entire purpose of that enclosure by the installation of those seal fittings. And obviously on the right-hand side, you see a cable gland being pulled out and not being properly secured. Now these pictures are a little bit, the one on the right-hand side might be a little more difficult to see, but the one on the left-hand side, what we've seen here is actually a combination of both putty and it looks like a liquid pour type compound. And they've actually done it from the inside of the enclosure. So I can promise you that those glands will never be removed. That will be a permanent installation. So that's not good. On the right-hand side, if you look very, very closely there, they have an IP washer, but it looks as if the IP washer is too large and not providing a good IP seal around that gland.
Is the IP washer the only mean to, Bob, is the washer the only mean to provide IP protection?
That is correct. That's providing the IP protection between the gland and the face of the enclosure. So by just taking a passing glance, looking at that, you might say, oh, it's got an IP washer. That's maintaining the high ingress protection rating. But when we look a little bit closer at it, we notice, wait a minute, that IP washer looks like it's a little bit too big. And it is. So it's important.
The question I had was, can we do something different than IP washer to provide IP protection, or is that the only meaning?
Some glands will actually have O-rings built into them, and that's certainly acceptable. Generally speaking, no. I would tell you, in order to maintain the IP rating of the enclosure, you're supposed to use an IP washer. And there's actually a little bit of dispute with regards to the standard. One of the changes in the 14 standard came for the use of a not certified washer, but the cable glands actually have to be certified now in conjunction with a particular washer. So there's, as opposed to just basically putting any IP washer on it. The IP washer doesn't have to be certified, but it basically should be tested and certified in conjunction with the cable gland. Now, what you see on the left-hand side, obviously we have damage to the cable there. It's being pulled out. And in this particular instance, on the right-hand side, when we start opening up the glands, we notice that the armor is actually not secured to the armor code. So those are examples. Again, when they're installed properly, everything is fine. If you notice in the background behind these glands, these are some shrouds, cable shrouds. As an inspector, I don't like these, and most clients are getting away from cable shrouds because what they end up winding up doing is that they hold a lot of moisture against the cable gland and actually cover up a lot of the faults. When we actually do inspections of cable glands, if we're doing a detailed inspection, we're going to have to remove that shroud and we're going to have to open up the gland. And what you see on the right-hand side is that once you open it up, you can see, okay, now we have some problems. Now, this is, again, kind of the same type of stuff. Here we have the armor is not properly secured on the inside. We had a cable shroud, if you will, that was covering this up. So again, you have to be very diligent when we're doing our inspections. On the left-hand side, this is a little bit, it may or may not be a fault, but you actually have an adapter and a gland, which isn't a problem. We have an IP washer against the box. That's not a problem. That's what we want to see. We have an ERC tag. That's fine. The one on the right-hand side with that IP washer is a little bit distorted. So again, is that an automatic fail? I'd say no, but I'd say we'd want to reinstall it. And if we can't get that washer to sit flush against that enclosure, then let's replace it.
Bob, there was a question since I noticed earlier, and I noticed this ground plug. If there is a ground plug on the box, it must be connected to ground, right? It's a recommend, or is it?
Yeah, well, there is a requirement within the -14 standards that all EX equipment should be grounded to the grounding point, if you will. So you will see, like in the picture on the right-hand side, we see a ground point on that, and then we also see another box where there's a ground point on that. And that should be grounded to the structure in some way, shape, or form. So yes, we should be grounding them. The picture on the left-hand side here is a little bit difficult to maybe see, but in this particular case, we have left the plastic sheathing over the internal bedding, and that's actually a flame-proof gland. So we've now compromised, if you will, the ability of that gland to provide any EXD protection by the use of this plastic sheathing. That has to be removed. And then what you see on the right-hand side is that obviously they've taken some compound and they've put it around the back end of the glands for some particular reason. I don't know why. Now, when we do use barrier glands, what we see on the left-hand side is that we see here that the compound doesn't go completely around all the individual core conductors. That is a mistake. What we also see on the right-hand side, there's again that diaphragm seal that's been torn. So again, that's providing us EXD protection, and it's now been compromised, so that would be an issue. As you can see from some of these slides, a lot of the mistakes that we do actually see are really around glanding in many cases. It's not completely around glanding, but that is a huge issue. So a lot of times when you start seeing issues with glanding, that leads you to believe that there may be some other issues as well. Now here's an interesting picture. This shows a barrier gland and a non-barrier gland right next to each other going into a flame-proof box. Is it a mistake? Well, based upon the latest requirement from the standard in the -14 standard, it actually is not a mistake because we can use a non-barrier gland going into a flame-proof box as long as that cable length is less than 3 meters. The one on the right-hand side, we had to use a barrier gland. Actually, if it's longer than 3 meters, we don't have to use a barrier gland. If we have a short cable length, we would have to use a barrier gland. So there are some other stipulations by the use of when and when not to use barrier glands, but generalities, this is not a mistake.
Well,
so we have another poll question.
We have another poll question, and while you do that, I ask you a question, Bob. We have a lot of questions, but I want to ask you a question. Have you ever get afraid when you're expecting this long, you see these boxes, I mean, you ever get the feeling you are inside the plant and say, man, I have to run away from here before
Yes.
something goes boom.
Yeah. Yeah. Yes. My colleague who works with me, Wayne, has worked offshore many years, and he was an installer for about 15 years. Then he went through a complex training program to learn all the things that he was doing wrong. And he was like, oh my God, I can't believe I survived. And yeah, he's told me I don't do as many inspections as Wayne does, but Wayne has shared with me some stories that are very much hair raising. But it happens a lot more than obviously what we think. So
So
unfortunately, it's a
guys,
big issue.
yeah, well, I imagine it is. We had my own experience. One we went on a plan with my engineers, and he said, "Paolo, I'm not staying here any longer."
Yeah.
So no, just nothing's gonna happen. But they had 1 year earlier. They had an explosion. And they were actually having a commemoration that day. And when we talked to those guys, nothing had changed, and we said, "Wow, are we still sitting here?" So anyhow, guys, you have this was an easy but not an easy question. Can you use an EX certified stopping plug in conjunction with the EX certified reducer fitting on an EXT enclosure? Well, the correct answer was, let me end the poll here and let me share what you got. The correct answer was no, right, Bob?
That is correct. Right. We
So
can't.
most of you guys got it correct, and great. You're really, how do
Yep.
we say? So, stop share. Let's move forward. We are running very late, but again,
Yeah.
as Bob said, he's available. If you guys want to stay with us, we can go longer.
Yeah, we'll go as long. I'll try to plow through some of this stuff here. But mistake number 4, and we've talked a little bit about this in some of the other webinars, but intrinsic safety has its own faults. Segregation between IS, no labels, improper grounding, no descriptive system documentation, failure to select certified equipment where required, i.e. a non-simple device, modifications to the design after installation, such as maybe we're increasing our cable length, substitution of a different barrier type, so forth and so on. These are all faults that we see both from the design standpoint as well as the installation. So what you see over on the left-hand side, you see a jumbling between IS and non-IS. That's not allowed. We have to have a 50 mil segregation between IS and non-IS. Again, if we didn't open up that enclosure, we would never know this. So we would be doing a detailed inspection, and this is where we find it. On the right-hand side, you see, again, the same type of situation where we have, in this case, is our IS side and our non-IS side, but yet we have this looping around, which is not allowed. Same type of situation what we have here. Again, we have, in this case, on the right-hand side, we have some power cable, and yet we have some IS circuits running right next to it. Neither of them are shielded, so therefore we could potentially induce currents into that IS circuit above and beyond its parameters. Same thing over on the left-hand side. We have power cables that are running right next to the IS cables. We don't want to see that. Mistake number 5, this is a very common one, and it's basically U components versus certified equipment. Notice on the right-hand side, and I apologize, it's a little bit blurry, but this is an enclosure that's full of terminals that was supplied by the manufacturer empty. Then the fabricator went ahead and installed certified terminals, did a great installation, but unfortunately the label still shows that this was a component. So unfortunately, in this particular scenario, this would not be acceptable because it is a component certified product. This label shows the same product, if you will, same part number, SX29.1N. But notice on the left-hand side, the certificate has a U at the end of it. The certificate on the right-hand side does not have a U at the end of it. The way we can very easily tell, besides just seeing a U or a non-U, on the right-hand side, we have some additional information, such as we have a T code. We notice a T6. We also have notice about number of terminals, the cross-sectional area, the maximum voltage. On the left-hand side, we don't have any of that information. So it's important if we're specifying products, right, that or installing or selecting or doing anything like that, understand that a lot of manufacturers will sell the exact same product either as an assembly certified with components installed or as an empty enclosure. Now, if I'm a manufacturer that am planning on using this particular enclosure and I'm going to populate it with a bunch of stuff and I'm going to take that to my certification lab to get certified, no problem. I'll buy the box on the left. If I'm installing this and I want to install it as is, then I want to buy the product on the right-hand side. This jumps up and bites people all the time. The use certified, component certified products. Just be aware of that. If you get a used certified product, that should be a red flag, unless it's a component on the inside of something else that is fully certified. This one is something I mentioned a little bit earlier about the X condition with regards to cable glands, about clamping. But a lot of other products will have X conditions as well. And it's important to understand and read these X conditions. So when we go and we select EX equipment, a lot of times what I tell engineers and designers, don't buy anything until you actually download and look at their certificates, because this is the secret sauce. This is where the manufacturer is going to put some stipulations as to how this equipment shall be used or installed. So what you see over there, it's telling us specific conditions for use. I won't read all that good stuff, but you can see there's a lot of information in there that you have to be aware of. So if I'm inspecting this, I'm going to look at those conditions for safe use, and I'm going to see whether or not you complied with those conditions for safe use. So be aware of that. Now, I will skip this one because we are kind of running out of time. Improper wiring techniques, those types of issues. Maintenance on EX equipment, not using bolts, making sure that the flanges aren't properly taken care of, those types of things. Obviously, on the left-hand side, accumulation of water, moisture on the inside. And again, on the right-hand side, when we start adding dust and we don't maintain it, we don't clean it. When we start adding dust layers to pieces of EX equipment, what do you think that does to its temperature code? It will make it go up. So we want to make sure that we keep these pieces of equipment that are installed relatively clean, dust-free. Again, earthing of IS barriers, this is a huge issue, especially, and we've talked about this before, but we want to make sure that if we have Zener barriers within our facilities, the Zener barriers must be earthed to a clean earth as opposed to a dirty earth. And that resistance has to be less than 1 ohm. So it's important to understand when we're using Zener barriers, the difference between our clean earth and dirty earth.
Okay, our last call, I
poll
believe, for today. One letter at the end of the certificate number, ATEX or ICX, a component certification. You talk about this all the time. You know, it's a component, it's not a fully certified product. It has to be used within a certified component. So, you know, it happens. We have one of those. We used to have one of those. It was a small power supply we designed. It was, you know, rated the correct answer.
Right.
and customer had to use it within their product and, you know, install it and then certify the fully,
Yeah.
you know, the complete product, like antennas. We were selling it to an antenna manufacturer. All right, well, we're running late, so let's stop this, end the polling. You have answered correctly. It's you, 90% of you answer correctly. So this is the result. Okay, Bob.
Right.
We have a lot of questions again, but some of them have been answered in the live question and answer, which I'll run in a second. You can, you have our, if you stick with us, we will run the second part of the presentation, which answers some questions you posed during the registration process. Let me see.
Do you have the Q&A file?
Okay. You see it? It looks okay? You guys see it?
I see it. Yep.
So first question, Bob. Then there are some live questions you might want to look at, but how much How much has legislation changed based upon industrial accident? Well, the question was posed a little wrong, but here's the answer.
Yeah,
Much,
yeah,
right?
yeah. I mean, it's unfortunate, but almost every good piece of legislation, and bad for that matter, usually comes from major incidents. So, without going into details, but the major incidents that we've seen that have really had a direct effect on some of the EX standards were Piper Alpha and Deepwater Horizon for the offshore markets. The Buncefield explosion, the Bhopal disaster in India were two major industrial accidents. But yeah, it every time there's an industrial accident, we hopefully are looking closer at the regulations, the standards to make sure that we're staying up to date. So absolutely, it has a major effect.
Absolutely. We had a question on EN 50495 standard, which is a standard called safety devices required for the safe function of equipment in respect to explosive risk. What about this standard, Bob? It's the first time I heard about this standard myself.
Yeah, no, it's one that people forget about. So basically, in a nutshell, is looking at if we have a good example is a motor starter. Do we have a piece of equipment that's protecting that motor? So motors, in many cases, depending on the protection type, have what is called a TE time, meaning that in order to maintain safety in a hazardous location, if you get into a locked rotor type situation, that motor must be shut down within a specific time frame. It's usually 10 to 15 to 20 seconds. So there's a safety device that's designed to shut that motor off. So I think if you go to the next slide, we show an example. That happens to be a picture of a little contactor that's manufactured by Allen Bradley. If we notice, it has an ATEX cert. And it's not meant to be installed into a hazardous area, but it's meant to provide protection to an EX motor. So it's a device that kind of falls under the scope of this standard that is more or less matched to that motor. And somebody needs to take that motor nameplate information, take this safety device, and make sure that they work appropriately.
All right. Next question. Breathable apparatus criteria. What protection concept allowed in the design of such systems? Oh, interesting question we got, huh, Bob?
Yeah. And so actually, we're working with a customer right now on doing respirator systems. And generally speaking, you're talking about low energy powered type protection concepts. So yes, things like intrinsic safety or non-sparking are generally the protection concepts that would be used. There could be things like encapsulation, EXM, or even a potential flame-proof components, but generally speaking, it's going to be limited to EXI or EXNA/EC are going to be the protection concepts for things like respirators.
Okay, next question. How to use an IS barrier on TCIP or a serial line? That I might answer myself, being the manufacturer of such device. But the question was, if the actual question says, do I need a barrier on both ends? Typically, if your device in the hazardous location is IS certified and the IS output is, say, RS485, you will only need a barrier on the control room side, on the safe area side. But we see a lot of application where you have devices in the hazardous location, maybe EXD type, flame-proof device, which have RS485 output, which is not IS. So then going to a safe area, so they're basically crossing an hazardous location. So in that case, you will need to barrier on each end, talking to each other, kind of like in the picture here. Next, how to properly ground wire screens. Well, Bob, that's for you. They typically need to be grounded. I only remember only on one side, right? You cannot ground the screen on both ends.
Yes. I'm typing up something to somebody who would.
Yeah, so it's actually typically their cable screen are to a dirty earth, but they must be left floating in the either control room or hazardous area side. Typically on the hazardous area side, they're grounded in the control room side, so in the cabinet. What precautions should be taken during maintenance? So that was also a question. Do we need to do maintenance? And how do we maintain a thread, for example, or how do we make sure the thread is correct? And how do we plan for that? That's an interesting question, right?
Yeah, it really is. And, so this is where I would recommend, without going into too much detail, is looking closer at the Dash 17 standard, because this also gives you kind of your maintenance inspection schedules, how to achieve it, what to do, how inspections are done. There's what is called initial, periodic, sample, continuous supervision. As I mentioned, there's different grades of inspection, frequently, lockout, tagout procedures. There's also in there competency of the personnel doing the inspections. So it is important. It's referenced, this competency issue of individuals doing all this good stuff is referenced in the Dash 17 and the Dash 14 standards. So it also gives you information as to the people that are doing those inspections internally, what they should be trained and how they should be determined to be competent.
We also have a question on EXT enclosure, having removable gland plates. Is that allowed? We talk a lot about this type of plates and issues.
Right.
What about
D boxes typically don't have a removable gland plate because they are a full sand cast, pressure cast type enclosure. They have to withstand internal explosions. So by putting a gland plate on there, you're not going to meet that, right? EXE enclosures definitely can come with removable gland plates. So if the question is if a gland is being replaced or a new gland is being installed, a full detailed inspection of the gland should take place. So what's good practice is, generally speaking, have somebody within the organization that knows what they're doing install the gland, and then have a second person come in and do an inspection, a full detailed inspection on that gland, and then make sure that all the document is updated in the dossier to say, hey, we've done this type of maintenance and all that good stuff.
And how about how often we have to do this maintenance? After initial installation and commissioning, is there a recommended periodicity to validate a system? Or what is
what we say in the standards is basically no longer than 3 years, every piece of equipment should be inspected. For portable and moving equipment, really, I get confused. I think it's 6 months, might be a year. But portable equipment, I think, is 6 months. So if we have portable hand tools or something like a hand lamp that's EX or something like that. So.
Great. So let's see a few more questions here. The pros and cons of a maintenance issue of a Zener versus galvanic isolated. That is a question I can try to answer. Basically the big difference between an isolated and a Zener barrier is the grounding. When you do need grounding for Zener barriers, whereas you do not need the grounding galvanic, and that brings a whole lot of differences in cost, maintenance, and other issues. Of course, Zener barrier can be less expensive to some extent, but in general, today the prices come very close, and an isolated barrier provides a safer application in the sense that you cannot do anything to that installation to impair safety. Whereas, for example, in Zener barrier, you can improperly ground it or ground in the field, the loop, have a ground loop, and then you have a problem. So let's move forward because we are running very late and we do have a lot of questions. We also have some live questions. We try to get to those that came in the registration first, so that you guys were so kind to ask the question prior. So here we go. What about IA, IB, IC? What advantages emerges from this protection concept? What are the differences between them?
Yeah. So basically, these are all 3 different protection concepts that are recognized as intrinsically safe. So IA is suitable for zone 0, 1, and 2, IB, so forth, so on. More or less, the difference between, say, this is usually the question that comes up. What's the difference between, say, a barrier that's rated IA and another barrier that's rated IB? An IA barrier will have basically 3 independent Zener diodes as part of the protection concept. They have redundancy, if you will. So things that are suitable for zone 0 have to be 2 fault tolerant. Products that are suitable for zone 1 have to be a single fault tolerant, and things that are suitable for zone 2 do not have to be fault tolerant. So there's basically the difference is that the higher level of protection has a higher level of fault tolerance, or more backup fault tolerance in a way.
Okay. What about, Bob, can I install a barrier in the classified area? That is a simple question. Typically, IS barrier certified for zone 2 or division 2. If you want to go to deep 1, you have to install them into another enclosure, an enclosure, for example, EXD or EXP, of course, following the condition of the EXD enclosure, for example, as you mentioned before, how many I can install, what is the maximum wattage, and so on and so forth.
Yeah, it is important to understand. We just can't take a EXD box and just pop a barrier in there and say we're good. Make sure that that box is certified to house associated apparatus on the inside. And again, can we just take anything and pop them inside a box anyway? No, they have to be certified as per the manufacturer. And generally speaking, we really can't do changes to the inside of that enclosure other than repairing things once the enclosure is in the field. So be aware of that.
In fact, we had a question about if we can use any enclosure, or do we need, for EXE equipment, EXI, do we need to use special enclosure? We cannot just place them in a normal enclosure, right? Somehow I mistakenly dismissed the question here when I was playing, but
So let me read the question. I think if I understand it, when using an enclosure that's rated as breathable, what equipment can be housed within it? EEG, non-sparking or sparking contactor. So there is, in the IEC world, there is a protection concept in the 60079 standards. There is what is called restricted breathing. So restricted breathing is basically a sheet metal enclosure. It could be a light, could be an enclosure that restricts the amount of air that flows in between the two, right? And that's a protection concept that is suitable for zone 2. The concept allows you to put general purpose equipment on the inside of that enclosure and use it for zone 2 applications. Now, a breathable type enclosure, every other enclosure, a flame-proof box, an increased safety box will breathe. They will get air on the inside and the outside due to heat rise, cooling and heating during the day, and everything else. So if the enclosure is breathing, if you will, on the inside of EXE boxes, the only real products that we can put on the inside of EXE boxes are certified products. Now, if we put EXNA equipment on the inside of an EXE box, then it would default to only suitable for zone 2. Now, on flame-proof boxes, we can use general purpose equipment on the inside of a flame-proof box. Purging and pressurizing. Generally speaking, we can use general purpose equipment, or we can use zone 2 equipment in the inside of purged and pressurized type enclosures.
so if I have, like in this case, multiple IS barrier or IS circuit into an enclosure, I do need an enclosure for classified for that area.
Correct.
Or it's a zone 2 area. Can I use a general purpose enclosure, or I need an EXE enclosure? I need a.
Yeah, for zone 2, you would have to use a certified enclosure. You can use an EXN enclosure, but generally speaking, people will make most of the manufacturers have EXE enclosures, and they're fairly low cost. Plastic. They don't all have to be heavy, stainless steel type things.
What about, that was another question that came in the registration. Is it possible to install a non-certified simple element like a push button or a switch using a barrier? That is an easy question, easy answer, I mean.
Yeah, and it is defined within the -11 standard. So basically a simple apparatus is a passive component, which could be a switch, junction box, resistor, simple semiconductor. If we think about it, we just want to make sure that these devices, they don't generate or store energy. So a switch, because it doesn't store any energy, is perfectly can be used, certainly with the use of an IS barrier. So it's not uncommon to use, you could use a general purpose light switch in a very onerous, hazardous area. And it's perfectly allowed.
Because it's the barrier that provides the safety for it.
The barrier is providing the safety. It's considered to be a simple device.
Yeah. So which is the hazardous area protection method most used? That is a question that there's no answer to it. I try to put together some answer, depends on the part of the world you guys are. For example, in our experience, the US world and US related operation typically like the big boxes, the flame-proof solutions, whereas European like IS more, but the real answer, it depends on the constraint of your application. If you have an EX, if you have a motor, you cannot make it IS, right? Well, there's a limit in IS.
Yeah.
So it really depends on your application. Let's move forward. And which application can intrinsic safety be used? This is related, basically low voltage applications, so low power from 420 milliamp signal, Namur, voltage, temperature sensor, solenoid valves, strain gauges, and so on. We will share this presentation with you guys so you'll be able to see it more clearly. Now, we do have some live questions, but we always get in the registration question like, what about the CIS standard? What about how does functional safety work with intrinsic safety and so on and so forth? We have several webinars. You can look them up online. And we talk about different issues. Today we talk about mistakes. Tomorrow we will talk. We also have another team that talks about functional safety. We have a team that talks about application. So you look them up. You can also review all the webinars that we do on our YouTube channels. So you can go there and view this webinar and all the mistakes I make. Bob never makes any mistakes. And while I'll let Bob answer some more questions, let me launch our last poll, if I can do so, here. Where is it? Sorry, I lost the poll. How did we do? You guys can answer that. Bob, there was a question that I mistakenly plugged away. It was from Rob about the Sun Neo washer. Do you know anything about that?
Yeah, no, I don't. And Rob, I'll do some digging on that. So let's touch base offline or so.
Yeah, he also posted another question about proximity of obstacle obstruction to flame path.
Yeah.
Do you make sure that the plate have a certain distance from the flame path? Or,
yeah. The question was, and I think I answered it direct back, but the answer. So there is a requirement for flame-proof boxes, flange flame-proof boxes that have to be a certain distance of that flange away from a solid obstruction. So basically, it's 10, 30, and 40 millimeters, depending on the gas group. There's one question about the validity date for EX certificates, and this is a great question because, so generally speaking, the certificates don't expire per se. What happens, they get updated. So under the ATEX directive or certificates that are issued by a notified body, you'll have an initial certificate and then you'll get an addendum update, boom, 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 boom. The important thing to note is really when we're looking at certificates is the product certified to the most relevant standards. This is usually where it trips up people. So generally speaking, when a manufacturer, and I saw this just the other day, I saw 20 different IEC EX certificates, issue 0 through 20 or 0 through 19. And this product's only been on the market for about 8 years. One thing we don't know is that the particular product that's actually installed, was it bought under issue 16 or 15 or 14 or whatever. But the important thing to note is that we want to look at the most recent standard or certificate and find out, was it tested to the most relevant or recent standards? That's the same thing that holds true for the EN or your ATEX certificates. Were they tested to the most relevant standards? Because standards, they do get developed, they get implemented, they become law or whatever. In the case of the ATEX directive, the EN standards have a presumption of standing, if you will, and then they get withdrawn out of the official journal. So we want to make sure that the products that we're selecting have been built and tested to the latest standards, and that's usually at the end of the ATEX certificate.
Yeah, in fact, we were just looking at that today. You have to look, certificate do not expire, but they state the standard they have been certified to. So you have to make sure that that is the standard, is the current at the moment. We were looking at some components and it was, listed the 80s standard, so the issue certificate based on a standard is 20 years old, well, more than 20 years old, and of course no longer relevant. It was certified, it's still certified to that standard, but that standard is no longer applicable. Now, in ATEX regulations, some standards are being replaced by new standard, but they're still applicable for a certain period of time. Maybe they give you 2 years. They say within these 2 years, both standards are applicable, and then all of a sudden, the older one drops off. So that gives the manufacturer some time to recertify to the newer standard.
Right.
Okay, guys, we've been together, 1 hour and 20 minutes. You've been very patient with us. Most of you are still online. Thank you very much. Thanks, Bob. There were some questions which we probably didn't get to, but we will look at the question. We have a record of all these questions, and we'll try to answer them via email. You will get a copy of the presentations. You will get a link to review the webinars. So thanks, Bob. As usual,
Well, thank you. Thank you, everybody. I appreciate it. And definitely reach out if you have some questions. Don't hesitate to reach out to us. We'll be happy to answer. We'll try to answer every question that we possibly can. So thank you so much.
Thank you, guys. And let me see, how do I do this today? Okay, here we go. Thanks again, Bob. Good. Have a good day. I'm going on for dinner. Ciao, guys.